The last objective that we're going to cover in section 7.2 is now using the exponent rules with rational exponents, and they're all the same. When multiplying powers of the same base, you add the exponents. When you have a negative exponent, it goes on the bottom. If you are dividing powers of the same base, you subtract the exponents. If you have a negative exponent on a fraction, you can flip the fraction and apply that exponent. If you have a power raised to an exponent, you can multiply the exponents. If you have multiple things multiplying together raise the same exponent, then you can just expand it through. Now, keeping in mind that's very different. So if they're multiplying like this, you can apply it through. If it's a plus b to the r, then it would be a plus b times a plus b by itself as many times as r would be. So it's very, very big distinction. As soon as you have a plus sign, you can't apply the power rule. All right, same thing. This is just applying the power rule, and then negative exponent, you can just flip the fraction it's on. Okay, so if I have 3 to the exponent 1/2 times 3 to the exponent 1/3, this is multiplying powers of the same base. So I can add the exponents. This would be 3 to the 1/2 plus 1/3. In order to add fractions, you need a common denominator. So the common denominator is going to be 6, and you could write this as one fraction at this point. You have to multiply this fraction by 3 over 3, so you get 3 over 6, which is equivalent to 1/2, and then you have to multiply this one by 2 over 2 to get 2 over 6. So this would be 3 to the 5/6. Then you always want to make sure what they ask you to do. So it says simplify each expression, write answers with only positive exponents, assume that all variables represent positive real numbers. So this can be my final answer. If it said write it as a radical, I could then change it as the 6th root of 3 to the exponent 5 if I wanted to, but if it doesn't specify, you can leave it. All right, so here we've got a division. So we have 7 to the 2/3 divided by 7 to the 4/3. When dividing powers of the same base, you subtract the exponents. So the traditional way would be 2/3 minus 4/3. 2/3 minus 4/3 is negative 2/3, and then I have to write it with a positive exponent. So it'd be 1 over 7 to the positive 2/3. Or you could have noticed this fraction is bigger, and you could have subtracted that one and know that your answer goes on the bottom. All right, this next one, we have the distributive property. So we're going to distribute r to the 2/5 through. So you get r to the 2/5 times r to the 3/5 plus r to the 2/5 times r to the 8/5. Now you can apply your multiplication exponent rule. So when multiplying powers of the same base, you can add the exponents. 2/5 plus 3/5 is 5/5. And then 2/5 plus 8/5 is 10/5. So then you can simplify. 5 divided by 5 is just r to the 1, and then 10 divided by 5 is 2, so plus r squared. And there's nothing you can do with that. I mean, you could factor out an r, but there's no reason to do so. All right, so here we have a power raised to an exponent, and not only that, but we have same bases on the inside. So you can apply your power rule first and then do your subtraction of the same base, or you can do the subtraction first and then apply the power rule. I'm going to apply the power rule first because it's going to get rid of my fractions for me. So this is going to be a to the 6/3. So 6 over 1 times 1 over 3 is 6 over 3. This would be b to the 6 times 2 is 12 over 3 times 1 is 3. And then on the bottom, it's b to the 1 times 6, so just 6. Then I'm going to simplify. So I've got a squared, b to the exponent 4 over b to the exponent 6. And again, if you notice that you have 6 b's on the bottom and 4 b's on the top, 4 of them are going to cancel out. You'll end up with 2 b's on the bottom. But if you're using the traditional power rules, exponent rules, you're going to do b to the 4 minus 6, which is negative 2, and then you have to put it on the bottom. Okay. All right, so maybe pause the video, give this one a go. It's a big one, and see how you get. All right, so again, sort of up to you whether you want to do your power rule first or simplify inside first. Looking at this one, as soon as I apply that power rule, I'm going to get a ton of fractions. Well, no, these ones are going to simplify nicely, but I'll have one more fraction. So I'm going to use my power rule, or my when dividing powers of the same base, I'm going to subtract the exponents first. So this would be a to the 3 minus 2, so a to the 5. And then this one's a bit tricky. I have negative 4 minus 1/5. I'm going to do the work on the side. So I'm going to make a common denominator by multiplying by 5 over 5. I get negative 20 over 5 minus 1 over 5 is negative 21 over 5. I find sometimes not doing the subtraction work in my question, but on the side will make my work neater over here and maybe make me make way less mistakes. And now I still have that raised to the exponent negative 1/2. Now I'm not going to worry about negatives because they're going to just get switched. So I'm going to multiply this negative 1/2 through. So I've got a to the 5 times negative 1/2 is negative 5/2. And I've got b, and again, if you want to do the work on the side because you're not feeling confident with fractions, you've got b to the negative 21 over 5 raised to the exponent negative 1/2. So you're going to multiply. So that's going to give me positive 21 over 10. And now I want to leave my exponents simplified and positive. So this a to the negative 5/2 is going to go to the bottom. So I've got b to the 21 over 10 all over a to the 5/2. And that would be my final answer. Okay. So now what if they start out as radicals? So people always get stumped with these ones because they're not written like the first ones you learn. So this is saying that you've got the 4th root of x cubed times the 5th root of x. And the reason you learn rational exponents is because of this. If I ask this as a problem, there's nothing you can do, right? You're not multiplying powers of the same base. I mean, you are, but it doesn't feel that way. You don't know what to do with the exponents. And so your first step with these is going to write them as rational exponents. Again, it's the whole reason you learned rational exponents. So if you ever see radicals and there's operations, change them into rational exponents. So again, the index becomes the denominator of your rational exponent. And so that's going to be x to the 3/4. And then this one has an exponent of 1, and then the 5 is going to become your denominator. Now you're multiplying powers of the same base, so you're going to add the exponents. And again, I like to do my fraction work on the side because I find it complicates my questions. So I'm going to multiply this guy by 5 over 5. I'm going to multiply this guy by 4 over 4. So my common denominator is 20. I've got 15 plus 4, which gives me 19 over 20. So this answer would be x to the 19 over 20. Now, because this question was written as a radical, it makes me want to simplify into a radical. And so I would write this as the 20th root of x to the 19. But I can't remember off the top of my head whether your textbook does this as well. So I just went and quickly checked your textbook because I was curious, and they left it like this, which I find curious, but really both are great answers, but your textbook just left it as a rational exponent. So there you go. All right, you could pause the video and try the next two if you wanted to. Okay, looking at this, first thing I see are these radicals, but there's an operation. I can see that they're going to have the same base. So I'm going to rewrite them as rational exponents. So this has an index of 2. So exponent of 5, index of 2. Okay, this one has an exponent of 1, index of 3. When dividing powers of the same base, you subtract the exponents. And again, I like to do my work on the side, or you don't have to. We can make a common denominator of 6. So I'm going to multiply this one by 3. I'm going to multiply this one by 2. And I get x to the 13 over 6. And according to your textbook, that's the final answer. But I really want to go back to the 6th root of x to the 13. But that's okay. All right, the next one. So this one, people always get stumped by these because they feel like they look really funny. Treat this as a power raised to an exponent. Okay, so if you start in the inside, if you just did this as a rational exponent, this would be x to the 1/6. And then you can see that this one would have another denominator on an outer one. So you'd have x to the 1/6 all raised to the 1/3. So this is a power raised to the exponent, so I'm going to multiply the exponents. So 1/6 times 1/3 is 1 over 18. And that would be my final answer. All right, go and try your homework for 7.2.